Hey everybody. Today I'll be solving a collection of AP Calculus AB questions. Before we start, I want to share that I scored a 780 on the SAT math section and I achieved several achievements in the field of mathematics. My goal is to make math more enjoyable and comprehensive for everyone. And if you're interested in tutoring, I'd love to help you out. And you can find my contact information in the description below. Don't forget to like, subscribe, and hit the bell for more. Let's get started. Welcome, everybody. So let's just get started with the first question. What is the x-coordinate of the point of inflection on the graph? Y equals 1/3 x cubed plus 5x squared plus 24. All right, so in order to find our point of inflection, we're going to take the second derivative, and after we take the second derivative, we're going to set that equal to 0, and we're going to obtain an x value for that, and then that's going to be our answer. So first of all, let's just take the derivative. If you don't know, we're just taking the exponent down and subtracting 1 from the exponent. So it's going to be 1/3 times 3 x squared plus 10x to the first power plus 0. All right, so this 3's just go away, and then we can just say x squared plus 10x is equal to y prime. Now we're going to take the second derivative, which we're actually doing the same process. It's going to be 2x plus 10 equals to y double prime. And after that, we're going to set this equal to 0 to x plus 10 equals to 0. And our x ends up being -5. Answer choice D. The graph of a piecewise linear function f for x is between -1 and 4 is shown above. What is the value of integral 4 to -1 f of x dx? Okay, so actually, if they're asking for this area under the graph, because integral means the area under a graph in a specified position. So if we're solving for this integral interval, we're going to find the area under this curve or linear function, and just this will be our integral value. Okay, so I'm not going to shade it, and let's just start it. What is the value of this? All right, so let's just draw a triangle over here. Okay, and a rectangle over here, another triangle over here, a smaller triangle, and a rectangle over here. So let's just find the values. Also, don't forget if it's under the x-axis, it has to be a negative. So just don't add this to it. You're gonna subtract this area from this area. So this has a length of 1 and a height of 2. So it's going to be 2 times 1 divided by 2. This is 1. Also, this is the same triangle, so this will be 1, 2, and this is a rectangle of 2 to 1, so this will be 2. And in this triangle, we have 1 to 1, so this will be 0.5. And this is a rectangle. Actually, this is a square 1 to 1. So this will be 1. So in the bottom of the x-axis, we have -1.5 because it's under the x-axis. And in the top, we have 2, 1, and 1. It's going to be 4. And our area has to be equal to 2.5. Answer choice B. So this is an integral question for this specified interval, and what we have to do is we're first going to integrate this. After integrating it, we're going to plug 2 and subtract the f of 1 if we say that f is equal to the integrated function. So actually, let's just write this down. 1 over x squared dx. So before integrating, I just wanted to write it like this. Instead of writing 1 over x squared, I'm just gonna say x to the -2nd power dx. And after that, we're just going to integrate it. So in order to integrate, we're just going to add 1 to the exponent and then divide everything by the current exponent. So it's going to be x -2 plus 1. So usually people make this mistake. They just write it like -3 because they think they added it, but actually not. This has to be -1 because you're adding -2 plus 1. So just don't make that mistake. Just be careful. It's like everybody can make that mistake, and just divide this by -1 because this is our last exponent, and dx. So actually this is the integrated version of, so that's why I'm just gonna not even going to write this. This is our integrated function, and we're just going to solve for 2 to 1. So after this defined integral, after this we're going to just plug 2 inside this function. After that, we're just going to subtract and plug 1 into this function. All right, so just let's make this look prettier, by the way. Just this is x to the negative first power is going to be 1 over x, and we have a negative, so it's going to be this. Actually, this is the actual integrated version. And now let's just plug 2, -1 over 2 minus, okay, and now we're plugging 1, -1 over 1, which is -1, and this turns up being ends up being positive, and then we end up with 1/2. Answer choice C. Question number 4. If f is continuous for this interval and differentiable for this interval, which of the following could be false? So in answer choice A, they're stating the mean value theorem. This is called the mean value theorem, and sorry, and therefore for some C this has to be true. This C has to be between A and B, and moreover they're stating that f is continuous and differentiable, which means our mean value theorem applies in this case, and A is true. Let's go to answer choice C. F has a minimum value in this interval. This is definitely true. Also has a maximum value, and this integral exists since the derivative is existing. It's differentiable. However, f prime of C equals 0 for some C such that this interval. So basically, this there is no determined information that this has to be true, because the question's asking which could be false, but however this could be false, but this also could be true in some cases, because they're actually not stating like this is not something mandatory for to be happening, so this is not 100% true statement. Anyway, so question number 5. So in this case, this is we just can just in this integral sign t dt, it's actually prove that we just can plug this x into the second variable and just write it as sine of x. There are many proofs in books where you can find. I'm not just gonna go over the proof right now because we're limited by time, unfortunately, but we just can call this a sine of x, sine x. 6. If x squared plus xy equals 10, then when x equals 2, dy dx. Very nice question. First of all, let's try to find dy dx. So if we take the derivative of this, x squared plus xy equals to 10, I'm just going to derive this everything over here, and I'm going to end up with 2x plus, now we're going to use the product rule. So the derivative of the first, which is 1, times the second, plus the derivative of the second, which is y prime, times the first, x, equals to 0, because 10 is a constant, therefore the derivative of a constant has to be equal to 0. Very sweet. Now we obtained the, now we have to just leave this y prime alone. So let's just subtract, like, let's actually make this look prettier. 2x plus y plus y prime of x equals to 0. I'm going to subtract 2x from both sides. Y plus y prime x equals to -2x. And now I'm going to subtract y from every side. Y prime x equals to -2x, y. And now I'm going to divide everything with x. So I'm going to end up with y prime, which the question was asking me, equals to negative 2x negative y divided by x. Now, since we got our derivative, actually, let me write this over here, negative 2x negative y over x equals to y prime. So now we have a little bit problem over here. So we got the derivative, but there is also another variable, which is y we don't know. We're just going to plug x and we're not going to get the answer because we don't have y. So how are we going to get y? Just plug this inside this function to get y. So 2 squared plus 2y equals to 10. Subtract 4 from both sides, 2y equals to 6. Divided with 2, y equals to 3. 3. Now we got our y and our x. Okay, so we're just going to plug it over here. Negative 2 times 2, negative 3 over 2. And this will end up being 4 minus 3, negative 4 minus negative 3, which is going to be negative 7 over 2. Answer choice A. Yeah, this is a little bit of a mess, so I'm just going to erase everything so we can move on to the second question number 7. Oh, if you have any questions or like if you're confused, just let me know on the comments so we can go over it again. So we got a pretty question. In this integral, we're just gonna integrate this, okay? And after integrating it, we're just gonna plug e and then subtract when we plug 1. All right. So first of all, I want to write this integral prettier. So I'm just going to divide x to both elements. So x squared over x minus 1 over x. Okay, dx. Now let's just simplify this. X minus 1 over x integral e to 1 dx. So we just can write this as two integrals, which will be integral e1 to x plus integral e1 to negative 1 over x. Also, they both are dx. So if we integrate x, what we're going to end up is x squared over 2 plus, and if we integrate this negative 1 over x, since this is written as x to the negative first power negative, we're struggling to integrate this, so we just use ln. So we just say ln of absolute value of x, but since this is a negative, we have to write this as a negative. Okay, negative. And this interval is going to be e to 1. Very cool. Now we got our integral, and now we're just going to plug this e and 1 into our functions. So it's going to be e squared over 2 minus ln of e, which is actually 1. So I just want to write 1 over here instead of ln of e because it's way more simple. After that, in this parentheses, I'm going to subtract 1 squared, which is 1 over 2, minus ln of 1 is equal to 0. So I just can't say 1/2 over minus 0, or in other words, just 1/2. And after that, e squared minus over 2 minus 1 minus 1/2 is actually equal to e squared over 2 minus 3/2, which is going to be answer choice E. I'm sorry, guys, for taking your time because this PDF file thing is just making me erase everything. I wish there was an easier way. There's not much space in this document, so unfortunately, I have to erase it. All right. Question number 8. Let f and g be differentiable functions with the following properties. If h of x equals to this and h prime of x equals to this, then f of x is what? So we got two informations over here. G of x is greater than 0 and f of 0 equals to 1. Let's see what we'll do with this. So first of all, what first comes to my mind is just taking the derivative of h of x and then this equal to this and maybe obtaining some other information. So if we take the derivative of this, what we're gonna end up is the derivative of the first plus times the derivative of the second plus the first times the derivative of the second, and it's also equal to this, which is also the derivative f of x times g prime of x. So actually, we got this over here, but it's actually, there's no element in this. So if we subtract this thing over from both sides, we get that information that f of prime times g of x is equal to 0. Wow. And g of x is greater than 0 for all x values. So in order to make this 0, we have to make sure that f prime of x is equal to 0. So our information is we got f prime is equal to 0, f of 0 equals to 1, and g of x is greater than 0. So we actually don't need this information anymore because we just use it. So what's f of x? So since f prime of x is 0, this has to be a constant. Therefore, we just eliminate this 3 answer choices and we obtain either D or E. So now how are we going to solve the question? The information 2 helps us over here, and they're telling us that f of 0 equals to 1. So it can't be 0, because if this was 0, this would also be equal to 0. This had to be equal to 0. So therefore, my answer choice is E. Flow of oil in barrels per hour through a pipeline on July 9 is given by the graph shown above. Of the following, which best approximates the total number of barrels of oil that passed through pipeline that day? So I'm just gonna draw a rectangle. Since it's giving an approximation, I'm just gonna write approximately, and here's the rectangle, which has the length of 24 to 100. Therefore, this will be 2400. And I'm just going to draw 2 triangles over here. Since they're asking the barrels of oil passed through the pipeline that day, I'm just calculating the slope, since it's just the barrels per hour times hours. So we just find the product by finding the area under the slope. And here will be 2 triangles. And actually, I can just treat them as just one rectangle. Anyway, I'm just going to solve it. So this will be 6. This will be 100. So this will be 300. And this will be 300 as well. So here I got 600, here I got 2400, and when I add these together, I approximately got 3000, which is an answer choice D. What is the instantaneous rate of change of x equals to 2 of the function f given by this function? So this type of questions usually take long because it's hard to take derivative for things like this. We just it just takes a while. So first of all, this is our function, and when we're taking a derivative like this, which is a fraction, we just first of all take the derivative of the first, okay, times the second, which is the bottom, minus the second, the derivative of the second, I'm sorry, times the first, over denominator squared. Okay, so let's just write this over here. What is the derivative of x squared minus 2? It's 2x times x minus 1 minus, what is the derivative of x minus 1? It's 1, so 1 times x squared minus 2 all over x minus 1 squared. So now I'm just gonna write this down. 2x squared, I'm just multiplying it, minus 2x minus x squared plus 2. So I end up with x squared minus 2x plus 2 on the numerator, and in the bottom I got x squared minus 2x plus 1. Okay, so we took the derivative, and now they're asking the instantaneous rate of change. By the way, the instantaneous rate of change means the derivative. So I just forgot to tell you that. Sorry. Derivative and derivative. And they're asking the rate of change at x equals 2, so we're just plugging 2 over here. Actually, I didn't need to even open this, so anyway, in the bottom we're gonna have 1, in the top we're gonna have 2 squared minus 2 times 2 plus 2, and this will end up being 4 minus 4, 0, 2 over 1, which is D. Question number 11. If f is a linear function and 0 a b, then integral b to a f double prime x dx. So this looks like an alien language to many people. Just make sure that you know what linear function means. A linear function is a function which you can write as m times x plus n, and they're taking its second derivative. So if we take the first derivative of this, we're going to end up with m, and after taking the second derivative, we're going to end up with 0. So basically, they're integrating 0 from b to a. So if you integrate 0, you're just going to get 0. And if you try to plug something, there's nothing to plug. So it's just going to be 0. Question number 12. If f of x equals to, okay, this interesting function, then limits x approaches 2, f of x is. Okay, so if f approaches 2, guys, we're first gonna take the limit from the left and then from the right. So first of all, let's just make it from the right. So if we take this limit from right, what we're gonna end up is we're gonna have an x value which is greater than 2. So we're just gonna use this function. We're just gonna plug 2 over here, which is going to be 2 times 2 squared is 4 times ln of 2. Okay, and this is actually 4 ln of 2. Okay, so if we just go from the left, we're gonna get ln of 2, which is not equal to each other. If let me just write it down. F of x approaches to 2 from less than 2 from left, and I got ln of 2. So let me just erase this thing. Ln of 2, hold on. Ln of 2 is not equal to 4 ln of 2, therefore my limit is non-existent. The graph of the function f is shown in the figure above has a vertical tangent line at the point 2, 2, 2, 0 over here. So a vertical tangent line means it's undifferentiable, and horizontal tangents at the point 1 over here and 3 over here, which means our derivative is equal to 0, which actually means they're changing concavity. So our second derivative will actually being 0. I'm sorry, not the first, but the second, and they're changing signs. So that means that they're changing concavity. The function is changing concavity. And for what value of x is not differentiable? So if it's asking differentiability, first of all, let's make sure that we got 2, because a vertical tangent point is never ever differentiable, and we got a weird place looks like this, and this is not differentiable as well, which means our answer choice has to be B, because we know that over here point 1 is differentiable, and this is differentiable as well, since like it's still continuous, and there's no vertical tangent line, or the limit exists. However, in this case, the reason why this is not differentiable is when we go from the left or from the right, we obtain different limit values, and this is a fundamental point of taking derivative, which meaning having a limit. If you don't have a limit, it's undifferentiable, and therefore the answer choice is 0 and 2. A particle moves along x-axis so that its position at time t is given by, for what value of t is the velocity of the particle is 0. So this is the position time graph. t squared minus 6t plus 5. So if you want a velocity graph, we're just going to take the derivative of this, which is 2t minus 6. This is the derivative. And since they're asking for what value of t velocity particle is equal to 0, this is actually a very basic algebra question. You're just going to say 2t equals to 6 and divide both sides by 2. T equals to 3. Our answer choice is C. So if we have f of x equals to this, and then f prime of 2, what is f prime of 2? So from the fundamental theorem of calculus, we just can cancel this integral by taking the derivative, and then we're going to end up with t cubed plus 1 for we're plugging 2. We're just going to plug 2. So if we plug 2, it's going to be 2 cubed plus 1, which is 3. Very cool question. So we're just taking the derivative. So first of all, take the derivative of the inside. Sine of x is going to be cosine of x. Inside it, it's going to be this. And then we're going to multiply this with the derivative inside, which is e to the negative x, times the derivative of the top, which is -1. Therefore, what is my answer? It should be answer choice E. The graph of twice differentiable function f is shown in the figure above. Which of the following is true? So f of 1 is 0. So first of all, this has to be less than the derivative because we have an increasing function, guys. If we have an increasing function, our f prime is positive and f1 is 0. So our f prime has to be either the greatest or the second greatest. So all of this makes sense. Okay. Yeah, this looks good. And also, our function is concave down, which meaning our derivative is decreasing. Our derivative is decreasing, which means our amount of increment is decreasing by time. And that means that we actually have our concave down. Our second derivative is negative. Therefore, we're gonna say f double prime is negative. Okay, and therefore, this looks like an answer choice. The equation of the line tangent to the graph of this y equals x plus cosine of x at the point 0, 1 is an equation of line tangent. So if we're saying the line tangent line, we're just gonna say fa plus f derivative of a times x minus a is going to be our tangent line for this graph. So let's just plug 0. If we just plug 0, we just get 1. They actually tell us. So f of a is 1 plus at this point, so we're taking the derivative and then plugging 0. So when we take the derivative, it's going to be 1 plus negative sine x. Negative sine x. So if I plug 0 over here, sine of 0 is 0, so this cancels out, and this is going to be 1 times x minus 0 equals to y. Therefore, my line of tangent is just 1 plus x equals to y. And it's answer choice B. Alrighty, question number 19. F double prime is equal to this, then the graph of f has inflection points when x is equal to what? X is equal to 0, -1, and 2, because this is setting the second derivative equal to 0. Therefore, answer choice is E. What are all values of k for which this is equal to 0? So we're gonna plug k in this derivative. First of all, let's just take the derivative, x cubed over 3, k -3. And then we're gonna plug k, subtract it when we plug -3, and we're trying to make this set it equal to 0, and then we're gonna have a equation, and we're gonna solve it. So k cubed divided by 3 minus -27, which is -3 cubed over 3. And then we're going to have negative 27 plus 27. So k cubed plus 27 over 3. And then all we have to do is just k cubed is equal to negative 27 in order to make this 0. And then k is equal to negative 3, only for negative 3. Question number 21. If dy dt equals ky and k is a non-zero constant, then what is y? So let me just write this question down. Dy dt equals to ky, and over here, I just wanted to write dy itself. So ky dt. Now let's just leave y alone. In order to make that, I'm gonna bring this y as a 1 over y over to the other side. So it will be 1 over y dy equals to k dt. After this point, I want to take the integral from both sides. So 1 over y dy equals to integral k dt. Since this is a non-zero constant, I'm not going to change anything on k. I'm just adding it, multiplying it with t. So this side will be ln of absolute value of y equals to kt plus c. Okay. So now I want to bring this ln to this side in order to leave y alone and find my question's answer. So absolute value of y equals to e, because since I bring this ln to the other side, I actually make it e, kt plus c. I can also write this as a to the power of k times t times e to the power of c, and since it's asking what it could be, we're actually multiplying it with something, and this could be b. So we just get rid of these answer choices since they're actually having y in their answer, because they're asking for y and we shouldn't have y in the answer choice. For this, we're not adding, we're actually multiplying it, therefore it has to be b. The function is given by f of x is this, on which of the following intervals is f decreasing. So it's asking f is, oh, I'm sorry, increasing. So basically, we're just going to take the derivative, which is 4x cubed plus 2x, and then we're going to make this positive. Actually, first of all, let's set this equal to 0. 2x, x squared plus 1. So when is this equal to 0? If I plug 0, right? Because whatever I plug, just in the way if I plug 0, I get a 0 for this function. It only works for 0, because if I divide this with x squared plus 1, it only works for x equals to 0 in the solution. So if I just draw a straight line and set this as my 0, this means this is for my f derivative. And because I'm searching for increasing, like over here, I'm looking for the zeros of the function, and after that, I'm trying to find a place where f of prime is positive, which means my original function is increasing. So on which of the following intervals is f increasing? After plugging values greater than 0, which is like 1, and f prime, I obtain a value of positive. I will keep getting positives. If I plug something negative, let's say I plug -1, -2 times 2, which is -4, so I will get negatives. So my my f prime of x is greater than values between 0 to infinity, all the way to infinity. So it's going to be 0, infinity. I just found for my f prime, since my original function will be increasing if my f prime is positive. We're almost done, guys. There's just a few questions left. Today we're doing a great job, I guess. Hope it's pretty comprehensive and you're not struggling to understand. If you have any concerns or comments, just let me know on the comment section below. The graph of f is shown in the figure. Which of the following could be the graph of derivative of f? Okay, so since this is increasing over here in the first place, which means our derivative has to be positive, just eliminate this. This could be the answer, but this is increasing all the way until it's like over here. So this means that it's increasing until this point, which is wrong. And well, this is not true either, since it's not actually being zero, because if my derivative f is zero, I will have a straight line, but I don't have that either. So my answer choice will either be E or A. Now let's just focus on over here. Over here in this point, which is over here, it's zero. Therefore, I have a straight line. I have a straight slope. And after that, it starts to decrease. And as you can see, it is decreasing. It's decreasing. And over here, this answer choice looks very good. How about this one? In this one, this is definitely wrong because this is a linear function, and this is definitely not the increasement. The amount of increase is not linear because I have a stop of my increasement, and other than that, it's changing concavity over here. So I don't think the answer choice will be E. It has to be A. The maximum acceleration attained on the interval by a particle whose velocity is given by FVT is. So the acceleration, they're asking for the maximum acceleration. So if you want to find the acceleration, you just take the derivative of the velocity function. Let me just draw this. If you take the derivative, you get the velocity. If you take the derivative of a t, which is a displacement function, you get the velocity function. If you take the derivative of the velocity function, you get acceleration. The maximum acceleration attained on the interval by the particle whose velocity is given by. So let's just take the derivative of the velocity in order to find our acceleration function. 3t squared minus 6t plus 12. And the maximum acceleration. So they're asking for the maximum value. So if you want to find the maximum value, you just plug F3 or F0, which are your endpoints. And you're going to take the derivative of this and make it equal to 0. And after that, this could be your maximum value. We usually find our maximum values by this method. So if I take the derivative of this acceleration, I'm going to end up with 6t, 6 times t minus 6, and t is equal to 1. So I also want to find f of 1. Therefore, let me just write over here more clearly. I need my f3 or f0 or f1. Either of these three will be my maximum maximum acceleration. So let's just plug it over here for this function. 3t squared minus 6t plus 12. 3t squared minus 6t plus 12. If I plug 3 over here, let me just make it over here. If I plug 3, 9, 27 minus 18 plus 12, negative 6, 21. I end up with 21. If I plug 0, I'm getting 12. And if I plug 1, I got 3 minus 6 plus 12, and will be 9. Therefore, my maximum value of this will be 21. My maximum acceleration is 21. Question number 25. What is the area of the region between the graphs x squared and y equals negative x from x0 to x equals to 2? So actually, let me just draw a function which it could be more comprehensive. So x squared looks like this and negative x looks like this. So they're asking the area for, 0 to 2, which is going to be an area like this. So how can I find it? Well, the best method which comes to my mind is just taking the integral for both functions and then adding them together. So I'm just going to say x squared dx 2 to 0, and 2 to 0, negative x dx, and we're just going to add these together. So if I just take the derivative of this, it's going to be x cubed over 3, and if I plug 2 and 0, it's going to be 8 over 3, my overall integral. 8 over 3, I'm sorry, 8 over 3 plus the other integral I'm trying to find, which is going to be negative x squared over 2. And if I plug 2, I'm just going to end up with negative 4 over 2, which is negative 2. So if I just subtract 2 from 8 over 3, I'm just going to get 2 over 3, which is going to be my answer choice A. So the function f is continuous on the interval of this and has values are given on the table above. The equation fx equals 1/2 must have at least two solutions in this interval. So fx equals 1/2 is going to be something like this. And when I plug 0, I get 1 for this. And when I plug 1, I get k, which I don't know. And 2 for 2. So basically, I'm going to be something like this. Since it has two solutions, it has to be somewhere around here. Therefore, there should be such a k value, which should be satisfying this. So it should be under 1/2 in order to make this two solutions. Because f of x is 1/2, we have two solutions. K has to be under 1/2, so it could go to K and then cross f of x again to make this have two solutions. So I'm just gonna do 27 at the end because this is a very good question, which I believe we should take our time. And I'm just gonna end this 28. If f of x is equal to tangent to x, then f prime of p over 6. So let's just take the f prime, which is tangent. If we take the derivative of tangent, it's going to be secant x. So our x in this case is 2 secant square x times 2, since we're also taking the derivative of the inside, and pi over 6 is going to be 30 degrees. So if we plug 30 degrees over here, it's going to be secant square of 60 times 2. What is secant? Secant is 1 over cosine. 1 over cosine of 60 times 2. So cosine, also this is going to be a square. So what is cosine of 60? Cosine of 60 is 1/2. 1/2 squared, 1/4. So 1 over 1/4 times 2. And this is actually 8. So now let's work on question 27. The question number 7 is asking for the average value of x squared times square root of x cubed plus 1. And in this interval, 0 to 2. So for average value questions like this, we just have a formula, which is 1 over b minus a, b to a, f of x dx. So for b, I'm going to plug 2, and for a, I'm going to plug 0. So it's going to be 1/2 b, I'm sorry, 2, 0, x cubed square root of x, I'm sorry, x squared, square root of x cubed plus 1 dx. So in here, I just can use u substitution. So x squared, x cubed plus 1 is equal to u. So du dx is going to be x squared, 3x squared. And dx is going to be du over 3x squared. So I'm just going to rewrite this 1/2 2 to 0 x squared, square root of u times du over 3x squared. This x squared just go away, and I end up with 1/6 2 to 0 square root of du, which is du. And if I integrate this, it's going to be u over 3/2 times 2 times 2 over 3 times 1/2. And this is also not 2 to 0. Since I'm using u, I'm just going to plug my 2 and 0 over here to find my interval, and my first interval will be 2 cubed plus 1 equals u, which is 9, and my second interval will be 0 plus 1, which is 1. So my answer choice have to be 2 over 18, which is actually 1 over 9. Let's just write this 1 over 9, u 3/2, 9 to 1. So I'm just gonna write over here. Actually, let me just erase this and carry that out. This is my answer. Yeah. So I just plugged 9 over here. So 9 over 3 squared times 1/9 is going to be 9. What is 3 times 3 over 6? 3 over 3. So I got 3 over 3 over 3 over 2, which is 3 minus 1. When I plug 1, I got 1/9. And this will end up being 26 over 9. It's my answer choice. Sorry. Yeah, C. So, guys, congratulations on solving this very difficult AP Calculus AB collection series. And if you want to do more, if you're interested in calculus or other maths, just like and subscribe and let me know on the comments. Thank you for watching this 28 question review. Wish you all the best. Have a good one.